Okay, welcome back. Let's see. Did you figure out our mistake? All right, this is so fun. These are so sassy. They're like little puzzles. Okay, let's figure it out. I'm thinking right up here, when we put that 7 in, when we needed 7 oxygens right here, we forgot that we had an oxygen right here. So how do we fix that? Well, we don't need 7 halves here. We already had an oxygen. If we wanted 7 there, then what we really needed was to put in 3. Okay. So now if we had a 3 up there, then we had 7 oxygens here, and then I think we're balanced. So let's forget this whole, but that is absolutely something we would do if we needed to. Let's try this again, and let's add this up and see if we're right. Aren't these fun? Okay, so let's try this again. C2H6O plus 3 O2, 2 carbon dioxide, 3 waters, and let's see what we have. Okay, let's do this. And so we've got 2 carbons here, perfect. We have 6 hydrogens, I love it. And now we've got 7 oxygens. Okay, perfect, because remember this would make 6 and this makes number 7. And then on this side we've got 2 carbons, we've got 6 hydrogens, and now we've got 4 and 3, that is 7 oxygens. I love it. All right, we actually had the answer easier than the whole fractions number we were doing, but if you do get to a fraction, you can absolutely do that. All right, let's try another one. Let's get just a little bit sassier with our structures. So this is an ammonium chromate compound, and this reaction we'll learn in our next unit is a decomposition. Let's see if we can balance it. Remember, we have trust issues. You can't trust me anymore. The first thing you need to do when you see a reaction is right away check for a balance. You can't count on me to give you a balanced reaction. So let's spell out what's on each side. We've got a nitrogen, we've got 4 hydrogens, we've got 2 chromium, and 7 oxygens. Okay. All right, let's spell out what's on this side then. I think we have a mistake in our formula. Let's fix that real quick. That should be 2 ammoniums in there. So let's make that 2. And let's make this an 8. Okay. And then we've got 2 nitrogens. We have 2 hydrogens. We've got 2 chromium. And we've got 4 oxygens. So this is not balanced. Let's see if we can't get this balanced. Okay, let's see. Let's take, our nitrogens are balanced, but our hydrogens aren't. So how do we balance that? Let's put a 4 here. That's going to get us to 8 hydrogens. Okay. What does that do for our oxygens then? Son of a motherless goat. Serendipity. We just went right to a balanced reaction. Isn't that awesome? That's way better than our previous examples. I love it. All right, let's try another one. All right, this one is not easy. So if you want to pause and try it before you let me answer it, that would be awesome. This would be a perfect time to pause and try to answer this one, and then we'll go through it together. All right, let's put 1 nitrogen. We have 3 hydrogens and 2 oxygens. Okay, we've got 1 nitrogen 2 hydrogens and 2 oxygens, so not balanced. We've got something wonky with our hydrogens. Let's see if we can't fix the hydrogens first, since the nitrogens seem to balance. So let's try to go, let's switch pens here. Let's see, if I add a 2 here, that's going to bring me to 4 hydrogens. Okay, let's start there. But then on this side, how do I add more hydrogens? The only thing I can do is add a 2 here, except son of a, that gets me to 6 hydrogens. Okay, son of a motherless goat. I'm going to have to go higher. And so how do I go up another one? What if we make this a 3? Okay, now we're getting somewhere. Now we've got 6 hydrogens and 6 hydrogens. I love it. All right, except what did we just jack with? Well, on this side, we just jacked with nitrogen. And then on this side, we just jacked with oxygen. So now we've got 4 oxygens over here, and we've got 2 nitrogens on this side. So let's remember, do the most complicated first. So let's fix the nitrogen. How do we go to 2 nitrogens? We're going to add a, oh, that's too bold. Let's add a 2 here. Okay. And then, all right, now we're getting somewhere. We went to 2 nitrogens, except what did we just do to our oxygen? Crap. We have an odd number. I feel a fraction coming, just like our mistake slide. Okay, so we've got nitrogens are good. Done. Hydrogens are good. Son of a motherless goat. It's the oxygens. Now, oxygen is only here. It's not in the other formula. It's not in our ammonia. So in theory, what we really need to go to 5 oxygens is a fraction. You need 5.5 oxygens in order to make that balance. But of course, we can't have a fraction in there. You can in later chemistry classes, but we typically don't have a fraction in Gen Chem 1. So how do you get rid of that fraction? We're going to multiply that whole darn thing by 2. That will get rid of the fraction. So what do we end up with? Let's draw the perfect. Okay. All right, so then, oop, I don't want the 3 there. So what do we end up with then? Let's do the math on that. All right, so we've got 2 times 2 for the ammonia, so that's 4. And then our oxygen, 5, we got rid of the fraction. Our NO, that's going to be 4. We have 2 times 2, and then 2 times 3 is going to be 6. Oh my gosh, that was fun. All right, honestly, I picked these examples because they're the worst of the worst. So all of these examples, these are the worst of the worst. So if you can balance these, you literally can balance everything. And that's super awesome news, because from this video on, every reaction I give you won't be balanced. So we're going to practice balancing reactions in front of every problem, because that's the first thing we're always going to do when we see a reaction is balance it. It's the first thing you're going to do. Remember, we're going to have trust issues in this class. You can't trust me to balance a reaction.